On this video, we're going to go over the vector notes on x and y components. So first off, we need to set some, I guess you could say, ground rules for using x and y components and get all on the same page. So we're going to establish that vectors that are traveling east or west are going to be x components because those are parallel to the x-axis on a coordinate plane. Then for vectors that are traveling north or south, we're going to call those y components because they are parallel to the y-axis of a coordinate plane. Now we're going to establish which vectors we're going to associate with positive and which one we're going to associate negative. And when I mean positive, it's used in the sense of direction. So positive direction and negative direction. We are going to consider that vectors traveling east and north are the positive direction and west and south are the negative. These are arbitrary. They technically could be flipped around, but this is parallels a coordinate plane where the east axis is the same as a positive x-axis, so it just makes logical sense for us to pick these things. So make sure that you understand these things, get them committed to memory, and to make this section of notes a little easier, okay? All right, so let's go over the basics of how to solve using x and y components. So the first step when using these x and y components to solve a vector problem. So for instance, an example problem would be like this one over here on the right, where you're just given a bunch of vectors and you need to find the resultant vector. So the first step is to determine if the component is an x or a y vector, and we're going to label those positive or negative depending on if it's north or south. So essentially, you're going to sort this list into an x column and a y column and make things positive or negative. And don't worry, we're going to do an example here soon. Your second step is going to be add up all the x's. This is going to get your resultant for the x value, or rx. Sometimes it's abbreviated like that. Then you're going to add up all the y components, or your resultant for the y value. Right. Next up, you're going to use those totals of rx and ry to use as the sides of a right triangle. So you're going to go the x direction and then the y direction. Right. From here, it's like solving a regular right triangle problem that we've already gone over. So you're going to use Pythagorean theorem and inverse tan to get your angle, and it's just like a right triangle problem. So we're just basically adding a few more steps before getting to a right triangle. So let's work an example of this. So I've taken that same list we had on the previous slide of 10 meters south, 5 meters east, 18 meters west, and 15 meters north. So I've already gone through here and sorted out each one into my x or y component. So for 10 meters south, that goes into the y column, and we're going to add a negative in front of it because south is considered the negative direction. For 5 meters east, it goes into the x column, and it's going to stay positive because the east is considered a positive direction. For 18 meters west, it's going to also go in the x direction because east and west are what goes in this column, and we're going to add a negative in front because west is considered the negative direction. Right? Now for the last one, 15 meters north, that goes into the y column because north is one of those, north and south are what go in that column. And we're going to keep it positive because north is considered the positive direction. Right? So easy, pretty easy there. All right, now your next step is to add up these columns. So the x column is 5 plus negative 18. So you can give us a total of negative 13. And then the y column is going to be negative 10 plus 15, and that gives us a total of 5. So that's your next step there. Now moving on to the next slide. All right, now our totals are negative 13 and 5. So we're going to sketch that out as our next step. So we're going to go starting just anywhere. You're going to go the x direction, then the y. So the negative 13 means you're going to go west 13. You can now get rid of that negative. You don't need it anymore because the arrow is telling you which way you're going. And then we're going to go 5 north at the end. So you're going to draw x, then y. If it's negative in the x, you go west. If this was positive, we'd go y. We'd go east. For the y direction, positive means you go north. If this were a negative number, we'd go south. And we're always going to draw one after the other. So we're going to go the negative 13, then the positive 5. Right? Now we're going to turn this into a right triangle by drawing our resultant vector to connect from where we started to where we ended. And we want this inside angle of where we started. You always want the angle for the resultant vector of where you first started drawing, okay? So now we're going to use Pythagorean theorem to get the magnitude of our resultant vector. So 13 squared plus 5 squared equals our resultant squared. We're going to work that out, and we eventually get all the way down to 13.9 as our magnitude, okay? Now we need to find the angle, and we're going to use inverse tan to do that. Our opposite side is 5. Our adjacent side is 13. So inverse tan 5/13 gives us an answer of 21 degrees. So now the last part of directions we need to say is the compass part, and this is north of the west axis here because it's touching west. So it's our final answer is going to be 13.9 meters at 21 degrees north of west. Okay. All right. Now, if we are given a vector that's not just going north, south, east, or west, we can break that down into X and Y components. It's basically almost the opposite of getting like a right triangle problem. It's basically working backwards from that and getting the two legs of your triangle. So you're going to use sine and cosine to find these values. So when you're given a vector that's going at an angle, like these two examples here, how it's like 3 meters per second at 40 degrees north of west, that's not simple to break down into the X and Y chart. So you're going to first want to sketch it and turn it into a right triangle, and you'll label the legs X and Y. The X is always the horizontal side. The Y is always the vertical side. And then we're going to use trig functions, which is going to be sine and cosine, to get your X and Y components. So hopefully when I work these examples, it'll make a little more sense. All right, so let's go over two examples of how to break down a component that's going at an angle into its X and Y components. All right, so first up, your first step to do this is going to be just to sketch out your vector. So I like to put it on a coordinate plane. You technically don't have to, but it is good practice. So for this one, we're going 3 meters per second at 40 degrees north of west. So my vector is going to go off this way. And my angle is going to touch that x-axis, or the west axis rather. So that's the 40 degrees. And then my hypotenuse is always going to be the magnitude given to me, okay? So that's step one. The next step is going to be to turn this into a triangle, and you want to include the angle given to you. So I want to enclose that 40 degrees. So I'm going to go up and over to make this into a triangle. Your x vector is then the one that is horizontal, and then the y vector is always the one that's vertical. Right? So now we can use trig functions to find out the values for x and y. So for the x vector, it's going to be the hypotenuse. And then in this case, our x vector is adjacent to this angle. It's touching it, so it's adjacent. So our trig function that's adjacent is cosine, so it's going to be cosine of our angle. So our hypotenuse in this case is 3, cosine of our angle of 40 degrees. Then we're going to type that in the calculator, and it's going to give us 2.3. Now, since this is a vector that's going west, that means our component, we're going to assign it a negative value. The calculator is not going to give you the negative. You just have to look and say, hey, this is going west, so west is negative. All right. So now for the y vector, we're going to use sine this time, and so it's hypotenuse sine of our angle. So the hypotenuse is once again 3 sine, since our y vector is across or opposite of our angle, so sine of 40. And then when we plug that in the calculator, it's going to give us 1.9. So our y vector is 1.9. Now this vector is headed north, so north is a positive direction. So we are going to leave this as positive, but you can put a plus sign there if you would like. All right. So that's our first example. Let's do one more. All right, now we have a vector that's going 15 meters at 30 degrees south of west. So let's start off again by just sketching out the vector. So you can put this on a coordinate grid. It's always a safe way to do this. And we're going 30 degrees south of west, so we're going to go in this direction. The angle is going to touch the west axis because that's the direction that's second. And then our hypotenuse is going to be the magnitude, which is 15, right? Next is going to be to turn this into a triangle by enclosing that angle. So we're going to go over and then down in this case to include that 30 degrees. All right. So now we're going to label the horizontal side X and the vertical side Y. And now we can solve for X and Y. So for X vector, it's going to be the hypotenuse, which is 15. And this time, once again, X is adjacent to our angle. So we're going to use cosine, and then your angle is 30 degrees. So you're going to type that in the calculator. You're going to get 13 for your answer. And we are going to make that negative because our X vector here is going west, which we assign to a negative value. Right? For our Y vector, it's also our hypotenuse. And this time we're going to use sine because the Y side is across from our angle and our angle is 30 degrees. So we're going to plug that in the calculator. We're going to get an answer of 7.5, but we're also going to make this one negative because it is going south. So anytime we assign a value, we'll assign it negative value rather when it's going either west or south. If it was going north or east, they would stay positive. Okay, so that's how you break it down. Again, you sketched out, enclose your angle into a triangle, label the horizontal side X, vertical side Y, and then use sine and cosine to find your X and Y values. All right, so let's work out an example of using the X and Y component vector when we've got to break down each of the component vectors into the X and Y's. All right, so first up, we're going to start by sketching out each of our component vectors and solving for their X and Y. So for the first one, we are going 12 meters at 35 degrees south of east. So that's going to go in this direction. And that 35 degrees is going to touch the east axis. All right. Then to determine how to draw the X and Y, we want to enclose that 35 degrees into our new triangle. So we're going to go over and then down to form our triangle that includes the 35 degrees. The X side of your triangle is always the horizontal side and Y is always the vertical side. All right. So now we can use our two trig functions to figure out what the values are for X and Y. So for X, X is adjacent to our angle, so we are going to need to use cosine to solve for that. So it's going to be our hypotenuse. In this case, your hypotenuse is 12 because that's the magnitude given to us in the chart. So it's going to be 12 and then cosine of our angle of 35 degrees. When we type that in the calculator, we're going to get 9.8. And we are going to leave this as a positive number because the X vector is going in the east direction and we assign east as positive. Right? For the Y vector, it's going to be the hypotenuse of 12. And this time we're going to use sine instead of cosine because Y is opposite of our angle. So it's going to be sine of 35. When we type that in the calculator, it's going to give us 6.9. But we are going to make that a negative number because that Y vector is going south, and we assign south as a negative, right? So then in my table, I can move the 9.8 up there, and then I can move the negative 6.9 into the table, right? Now for the next vector, we once again want to start by sketching it out. And this time we're going west of south, so we're going to go this direction, and it's 60 degrees. So that 60 degrees west of south is going to touch the south axis. And then we want to make our triangle by drawing our X and Y components. So we want to include that 60 degrees as we form that triangle. Our Y is always the vertical one. Our X is always the horizontal one. All right, so now for our X component, this time X is opposite of our angle. It's over here across from it. So we are going to use sine. So it's going to be our hypotenuse is 4 because that's the magnitude given to us in the chart. So 4 sine of our angle of 60, and that is going to equal 3.5 in the calculator. We are going to make that negative because our X component is pointing west, okay? So we're going to make negative 3.5, and then for the Y, it's going to be our hypotenuse of 4, and then this time it's going to be cosine because our Y vector is adjacent to the angle. So 4 cosine and then 60. We type that in the calculator. We're going to get positive 2, but we are going to make it negative because that Y vector is headed south and we assign south as a negative. All right. So now I can move those into the table. So it'd be negative 3.5 and then negative 2. All right. So now I've broken down each of my vectors into their X and Y's. So now my next step is going to be to add up my totals. So when I add up the negative 9.8 and the positive 9.8 and the negative 3.5, that's going to give me 6.3, and that's positive 6.3. And then for the X column, I have negative 6.9 and negative 2, so that's going to add up to equal negative 8.9. All right, so from here, it's like a right triangle problem. So we are going to take our X and Y totals and sketch out a right triangle. So I always start with our X value first and then draw the Y value. And the positives are going to tell you which way to go in those X and Y directions. So if it's positive in the X, you go east. If it was negative, we'd go west. If it was positive in the Y, we'd go north. Since this is negative, we're going to go south. So we're going to go east 6.3. And then at the end of that vector, we're going to go south 8.9. Then we're going to connect those two, and that's going to be our resultant vector. And then our angle is going to be the angle where we started drawing, that's inside the triangle. All right. From here, you don't need to include the positives and negatives. Those positive and negatives are simply just to tell us which way we're going. Now that job of saying which way is taken over by the arrows, so we no longer need that in these labels, okay? So from here, for our next step, we're going to do Pythagorean theorem. So it's going to be 6.3 squared plus 8.9 squared equals r squared. That is going to equal 118.9 equals r squared. And then we need to square root both sides, giving us a total of 10.9 for our resultant vector. So the magnitude is this, is 10.9. So that's our magnitude. Now to start the other half, we need is direction. We need to know this angle of our resultant vector. So to do that, we're going to use inverse tan. And it's our opposite side, in this case is 8.9, divided by our adjacent side of 6.3, and that's going to give us our angle, which when we work that out is going to give us an answer of 54.7 degrees. All right. The last thing we need to include in directions with this 54.7 is which way that 54.7 is, which axis is it off of, and which way is it going. All right. So this angle right here, this vector is going straight east, and this is 54.7 degrees below east. So it's going to be south of east. So our full final answer now is 10.9 meters, and it's going at 54.7 degrees south of east. And that is our full and final answer. Okay, so it's a lot of steps, but if you're confused on any of this, just let me know, okay?